let's get a sketch down of A, B, C, D, E and just, try and piece together what's actually going on because there's a lot of information here. So I'm first of all just going to draw something that looks a little bit like a regular pentagon. It's just a rough sketch. I'll label it A, B, C, D, E. We can modify it as needed. We're then told that ABC is an isosceles triangle. Now, technically at the moment, I don't know which sides are equal, even though it looks on my diagram like AB and BC are equal. So I won't put anything on yet. And then AED is also an isosceles triangle, as is CAD, and importantly, AC is equal to AD. Okay, so I can definitely label them the same. CAD is acute, and ABC and AED are both right angles. And what that tells us actually is that these two will definitely be the same, and these two will definitely be the same. We don't technically know if they're all the same. Yes, we do, because when we do Pythagoras, you get the same hypotenuse for both. So what this is actually saying is that, yeah, all four of those sides are equal. Okay, it says to draw a sketch of the pentagon. That's sort of what I've done, actually. Here's a more accurate version. It's not actually going to be necessarily a regular, well, no, it's definitely not going to be a regular pentagon because I've got 90 degrees, whereas a pentagon is normally 180. So here's one where I'm actually making it look like 90 degrees, and I would recommend drawing it like that because it's a good sketch in this question is really going to help. We're asked to mark all the equal sides and equal angles, so I've basically done that, but I'm just going to do it again. So those two are the same. Okay, other equal angles. So I know that this is going to be 45, and so is this one. So is this one and this one. And then these two are also the same. Maybe I'll use 2 here. I can't do much more than that. Okay, that's a pretty good drawing though. The second part then is about how can we fit 4 of these pentagons together to form a hexagon. So 4 pentagons together, 5-sided shape, but 4 of them to create a 6-sided shape. I think this is quite hard, and you might be tempted to, draw some very similar pentagons alongside one another. Before I get involved in that, I'm going to show you how you can get a bit of insight though. So if this is x and this is x, we can actually work out this angle here, which is 180 minus 2x. What that means is that the overall angle for this top part will be 270 minus 2x. Now, why does that help? Okay, one tempting thing, I think, is to draw the same pentagon but upside down. Okay, like if we start doing stuff like this, there's no way that's going to work. This is kind of where I'm coming from with this, and yeah, this just doesn't look like it's going to end up with a hexagon. So let's draw it down here. Now, what we have at the bottom then for this angle is actually going to be 90 plus 2x. And if we add these two together, we get 360. So that is it. If you can spot that, brilliant. It's not at all obvious, I don't think. But what it is basically saying is that we'll definitely be able to fit this in here. And because I've drawn mine accurately, it actually fits pretty nicely. But this is quite a hard aspect of the problem, I think. I could do exactly the same on the other side. Remember, I know this is going to be a straight line because both of these are 90. And that's going to happen all the way around. So I'm just going to get these 4 sides here and then these 2 here as well. So how do we know the pentagons will fit exactly? Well, I've explained it with the angles. So I'd probably write some words about the 90 degrees fitting together, clearly going to give a straight line. And then these positions here are when the pentagons are going to come together. and we're going to get 360 degrees around a point. Okay, whew, well done.